Carter has noticed a few quantitative relationships related to the success of his football team and has modeled them with the following functions. All right, this is interesting. So he has this function, which he denotes with capital N, and it's the and the input of it is the winning percentage W, and then the output is the average number of fans per game. So he's making some type of model that says, look, the number of fans per game are going to be in some way dependent on what your winning percentage is. And I'm assuming his model, the higher the winning percentage, the more fans are going to show up at a game. Now this is the W. The input is the average daily practice time, X, and the output is the winning percentage. All right, that makes sense. Probably, once again, probably some type of a positive effect of practicing more is going to create a higher winning percentage. And this other function, number of rainy days are, and then average practice time. Yep, well, the more rainy days you have, well, that's going to lower your average practice time. So I definitely see how practice time P would be a function of number of rainy days. The expression N of W of X represents which of the following? Well, before we even look at the choices, let's think of what's happening. This is another way of denoting we're going to take X. We're going to take X right over here, and we are going to input it into W, and we're going to get out W of X, and then we're going to input that into the function N, and we are going to get out N of W of X. So what does the function W do? What does the function W do right over here? Well, that's winning percentage as a function of practice time. So you input practice time, and it gives you what somehow predicts a winning percentage. Winning percentage. And then you take that winning percentage and you input it into function N. Function N is going to output the number of fans per game based on winning percentage. So this is number of fans. So when you take the composite function, you're actually creating a function that starts with practice time as the input and shows the number of fans that are going to be dependent on your practice time. So this is interesting. So we should look for a choice that says, how does the number of fans that show up at a game, how is that dependent on practice time, X? All right, the team's winning percentage is a function of the average daily practice time. Now that would be just W of X. If they said just W of X, that would be winning percentage as a function of average daily practice time. So I can cross that one out. The average number of fans per game. All right, this is interesting because that's what the final output is going to be in terms of the average number of fans per game. That is the output of the function N right over here. The average number of fans per game as a function of the number of rainy days in a season. Nope, we're not doing that. We're doing it as a function of practice time. You could construct that. In fact, if you wanted to do this, that would be N as a function of W as a function of P of R. So that would have been this choice, where you input the number of rainy days. From that, you're able to figure out practice time. And then you input practice time to figure out win percentage, and then you input win percentage to figure out the number of fans in the crowd. But that's not what we're doing here. We're just starting with daily practice time and getting to fans per game. So let me rule this one out. And if you found this one what I just did a little bit confusing, I encourage you to try to set up a diagram like I just did in the beginning of saying, oh, well, look, we could start with R to use that as an input to get average daily practice time, and then use that as an input into W to get winning percentage, then use that as an input into N to get average number of fans per game. But that's not what they're describing for N of W of X. The average number of fans per game as a function of the team's average daily practice time. Yeah, that's what's going on. You have your average practice time X being inputted into the function W. So your average practice time is going inputted into W, and it outputs winning percentage, which you then input into N and to get the average number of fans per game. The average number of fans per game as a function of the team's average daily practice time. So, yep, I definitely like that choice. Let's do another one of these. This is interesting. Denise studied the park near her home, where she identified several quantitative relationships and modeled them with the following functions. So B, it inputs the height of a tree in terms of X, and it outputs the number of birds nesting in that tree. H, input the average temperature at a specific location, and it outputs the height of the tree at that location. And T, the altitude of a specific location, and then if that's the input, and then the output is the average temperature of that location. All right, this is interesting. According to Denise's findings, which of the following expressions represents the height of a tree as a function of its altitude? So we want to figure out, we want to output the height of a tree, and we want to input the altitude of a specific location. So let's think about it. If we take our altitude at a specific location, r, and we input it into the function t, out of that we're going to get t of r. T, let me write that a little bit neater. We're going to get t of r, which would represent average temperature at that location. Average temp. And then if we take the average temperature at that location and input it into function h, and then we input into function h, we are going to get the height of a tree at that location. So we're going to get h of t of r. And so this is going to be height of tree at that location. Height of tree. And so there you have it. H of t of r. You start with r, altitude, a specific location, input into function t. T is going to spit out the average temperature at that location. You input that into h, it's going to get the height of the tree at that location. So h of t of r. H of t of r is this choice right over there.